Welcome, everybody. This is Fred Schenkelberg, and today we're going to talk about, just in general, kind of a high level about reliability engineering. And in particular, what caught my attention a while ago was somebody asked me, so what do you tell people that you do for your job? What do you do? And I said, well, I'm a reliability engineer. And then also realized that when I tell that to my mother, she would have a confused look and wonder why I was still playing with trains. So a little bit of a joke there. Hey, Carla, welcome. And well, I guess it's good afternoon or evening there for you. Uh, and everybody else, and there still seems to be a few more folks joining. Welcome. So today I want to talk about a topic that is part and parcel to what we do, but I think diving into it will help us understand how we can frame or scope or approach what we do to the best effect. And there's a difference. You can just go do one particular task and do it well, yet it won't really make that much of a difference. I think understanding the grander scope of what we have the potential to do or to accomplish or to contribute is important. And like I said, when I'm on an airplane or talking to somebody at some general meeting or professional society or whatever, and sometimes, and I'm sure you've had this happen, um, somebody will say, "So what do you do?" Right? And I usually answer, "Well, I'm a reliability engineer." Well, that's obvious, right? That's the greatest job in the world. And you've seen this response, okay? So what does that mean? Or what is it you do? Years and years ago, I remember asking, I was in a class at Raychem Corporation, and the course included many of the senior executives coming through and spending about a half hour or so with us, talking about their particular focus or area of the organization. And one of the questions I always ask them is, so what do you do? And they talked about the executive level decision making and making all these grand activities and setting policies and visions and direction and all this other good happy stuff that you see in the resumes or in the job applications for senior executives. And then I would say, so what's a typical day like for you? What's your calendar? What's an average day for you? Oh, I go to this meeting, I go to that meeting, and none of those meetings had anything to do with what they said they did. And I thought, well, you're doing a lot of activities, but they don't seem to be related to what you think you're doing. And I thought that was odd. And so I, I try to explain what I do with with the answer of why I do it, right? Why I'm a reliability engineer. Why is that I take the, this approach and do what I'm doing. And well, I was going to comment Hojat's comment about no sound, but I don't think he could hear me. So uh, one of the problems with the system is that your sound has to actually be connected to the Adobe app. Checking preferences in the app and computer. So anyway, hopefully that works. Otherwise, well, it seems like most everybody else is doing pretty good. So one way that I've heard many people talk about what they do, and it's not just reliability engineers, it's just about anybody, is they talk about the specific tasks, right? I, I, I'm sure there are people that are professional meeting attendees and little else, um, but I'm not one of those. Um, in the day-to-day activity, of what we do, we tend to have pretty defined and unique types of things we do, and it falls down and I'm just listing a few examples here of, oops, let me get rid of that. That's not what I wanted. I wanted to hit this button, the other play button. Um, is sometimes we work with teams and systems and operations to create models, and we're saying, well, here's all the different failure rates or distributions to failure and repair times, and here's a particular failure mechanism or whatever, and we spend a lot of time either doing building a model like a block diagram. And sometimes they're pretty simple, but sometimes they can be rather complex. I didn't list on here Petri nets and Markov modeling and Monte Carlo modeling. And there's dozens of others approaches to this. But usually we do some of our work may involve creating a representation of the world, of the real world, in some piece of it that we're interested in. And it helps us and others to say, oh, do I need redundancy here? Or is this the right architecture? Or what if I change this piece? Will it affect the overall system or not? And to what extent? And there's a lot of, it can be a lot of what if type stuff. It can help us in creating architectures of designs. It can help us in many different ways. But it does take some work to create a reasonably accurate model of the real world. And it's something that falls to reliability folks and other engineers in what we're trying to do. Okay, thanks, Hojat. I'm glad you're in. Pradeep, I'm not sure what that would mean. Might try coming out and coming back in unsupported. Hopefully everybody else can see the various slides. Focus. Hopefully that works. Not using anything fancy. Also, sometimes if you come in through the Adobe Connect app, open the app itself, it helps with a lot of this type of stuff. All right. Come in through for them to and operation spinning wheel loading. Yeah. I know that Adobe is making changes to the system and they're getting rid of the reliance on Flash and they're implementing more and more of HTML5. And they're recommending that when you open the session, it prompts you to open within the Adobe Connect app. And it is a download, so it is something they didn't used to do. Hopefully that solves it for many of you. All right. Some of the stuff we do, and I know lots of reliability professionals that spend a significant amount of time doing testing. They're test planning, they're setting up laboratories for chambers and equipment, and they're looking at the environment where the product's going to be used and creating everything from artificial sweat to the range of different chemicals that could be applied to a product, like cleaning agents and lotions and stuff like that, all the way to drop testing and being able to measure that and the amount of force that's impacted and so on. We do all kinds of different testing just to see will it survive, right? And I'm lumping those underneath environmental. But we also do types of testing that say, well, is there margin here, right? If it's supposed to work to 40 degrees C, will it work if we go to 41 degrees C or 45 degrees C? How much margin is actually there? 40, and if you do it well, how much variability is in the product or in the design, because there's certainly variability in the stresses being applied. And so I'm lumping those together under stress testing. And then HALT and ALT are two acronyms that we use for highly accelerated life testing, which is acronyms that's a great procedure to figure out where the weaknesses are in a design, take a couple of prototypes and use step stress testing of a select few stress vectors on it. And then we also do accelerated life testing, where typically it's focused on a single failure mechanism, say corrosion or metal fatigue, and then we apply an appropriate stress in a way that's beyond what we would typically see in a day-to-day use, but it allows us to cheat time a little bit, right? And so, and there's many different ways to do all of these types of testing. And I've talked about many of these in the past and previous webinars. And so the idea is that you can make a career out of doing pretty much just testing. And some people do, which is great. But it's just the task, right? It's setting up, well, part of it is the art of getting enough samples. But once you have the samples, then it's running a good experiment, running a good set of procedures so that you get meaningful results. But it's still a part of a larger process. Another thing we do, and this is where the statistics come in a lot of times, in even basic things like creating a bar chart or a Pareto of field failures, is a type of analysis. But we also have all kinds of results from our own testing, from simulations, from vendors. We do all kinds of different statistical processes and analysis processes to look for and understand the world about us as it's happening, or as we attempt to understand it through experimentation. A significant part of the body of knowledge for reliability engineers through ASQ, the CRE, is around statistics. And I know that I got into statistics because I was dealing with a lot of data, and I started taking more and more courses in order to understand just how do I do this regression analysis and design of experiments and so on. And we use this stuff over and over again all the way through our work, right? And it's a set of tools that I highly recommend you have, is from simple plots to regression analysis to design of experiments, SPC, and all the rest are really the right set of tools, and a good mix of tools allows us to answer a good mix of problems or questions, right? And so between modeling and testing and analysis, it doesn't cover everything that we do, yet it covers what could be individually a whole career. You could be just an analyst. And I don't mean just as being little, it's just an analyst that there's a lot to it when you dive into it. And there's a lot of nuances and there's a lot of depth to getting a good analysis of a set of data, and being able to ferret out observations and insights and opportunities to make improvements really does take some good care in the analysis technique. And this same notion applies to testing and modeling. And there's others. There's failure analysis type work. There's all kinds of other work that gets lumped into what is reliability engineering for some organizations. Yeah, these are just things we do, right? It's better than attending meetings, I think. Yet it allows us to transform some raw material into some information. And it's probably the most generic way of saying this, and a lot of engineers do this. We have a problem, we want this function to occur. Well, I go through a process to create a design that accomplishes that. The specific task might be laying out a circuit board or doing a circuit analysis or modeling a physical system. But those are all elements in order to accomplish something. And it's the same with reliability engineering. Testing is not the end in itself. For example, it's probably the easiest one to understand, is that I can run a test, and if nobody ever looks at it, this is that philosophical question about if a tree falls in the forest, right? If nobody cares about the results or considers the results or wants to see the results, did the test really occur, right? Was there any point to it? And those are some of the key elements here, is that the tasks we do are not the goal in and of themselves. That's not why we go to work, is to run a test. It might be for this day that you have to set up and turn the button on so the chamber heats up, and that starts a test. Yet that's not why we're doing it. That's not generally why we're reliability engineers. Right. I'm kind of leading into that what we do is so that we get outcomes, right? We want results. So, and you hear that in business all around the world is, we need to get results. We need to hit the reliability targets, for example. But there's a couple different ways to look at that. And and some of you I know have been to previous um, webinars and have probably heard this story, but when I ask my graduate students at Maryland in the class I teach there, what's the most expensive part about reliability? Right, well, let me pause and just ask you. And for those that have heard this before, you can hold back a little bit. But what's the most expensive part of reliability? I'm giving you some clues here on the screen at the moment. And hello, Jay from Las Vegas. And John, yeah, I'm not sure what's the deal with the spinning wheel and the others with the wheel. I can only surmise that it's something to do with the changes they're making. Yeah, the cost of unreliability. That's part of warranty, is a part of that warranty repair. Um, yeah, Hosha, good idea here. There's this concept that if you fix it if you design something well at the start, it it and spend the time to get it right at the start, it costs way less than fixing it later, for example. And if you fix it in development time, it's much easier to do and less expensive than when it's in manufacturing and so on. And Ray, I think you've heard this before. Lost customers, customer loyalty, uh, customer satisfaction, brand, all those brand type things. That's a piece of it. It certainly is, but it costs us as an organization, right? Rework on reliability. What I want you to think about is, well, what about further out? What about not just the expense that we have on our um, spreadsheets, right? The time we spend replacing a part, doing repairs, even doing a recall is not the most expensive problem when a product fails, is my supposition. So think of it this way. Your customers purchase your product in order to do something, right? They buy a computer so they can do modeling to support their development work of their product, right? They'll spend, thousands of dollars for this piece of equipment and the software, and they have this highly trained engineer, somebody like many of us. And if that machine doesn't work, they're not getting the value out of that engineer. They're not getting the modeling or the analysis or the results that they were looking for, right? There's nothing wrong per se with the computer. We do a repair or we replace it and it costs us $10,000, for example. But that's quickly swamped by having an engineer sitting idle, or worse, creating um, inaccurate results because there's an unknown bug in the machine that uh, the floating point error of years ago types of things, where you get errors in your analysis, but they're not really visible, right? You get a number, but it's not quite right, and you make bad decisions. And so if I'm either not able to do the analysis with the time I have available, I can't use that information to make a decision. It's the same we do in our own organization. But here, this product is providing that function to somebody else. And so it's not about the server, the cost of that server. It's the lost time of that engineer, the loss of information for them to make a decision. The customer doesn't get the value of your product if it's not working. But that's just a piece of it, right? Now we've got this scrap. We have raw materials that now are either some of it may be reclaimable, but oftentimes aren't. And so we've wasted resources all the way through the construction and delivery of this product, and now it gets thrown away. And now we have to make another one. So we're using twice as many resources from a scarce set of resources around the world to create something, and then some portion of them don't work. that affects us all, right? There's only so much titanium and lithium and all these other elements out there. And when we're not using them well, it costs us as an entire society. Well, think of it this way, is that part of the traffic on the road, some portion of it is returning products or delivering replacements. If those failures all went away, we'd have less traffic. This is kind of oversimplification of the whole process, but think about it. Um, the cost of unreliability is more than what it costs us in the organization. It also costs so many other people across our world this lost resource of either materials or of time. And so this concept, when you take it out to society, goes to the Taguchi's loss function, right? And that's where the real impact is. That's where the big numbers are. Yeah, and Brad, you're right. It's a way of phrasing it is that it's the entire value chain. And when we do our job well and we have a reasonable or low failure rate, not only is our warranty lower, our repair time to keep equipment running lower, our cost of operation lower, our scrap rate lower, but we have happier customers. They get the value of our product more consistently. And then society doesn't have extra trucks rolling around delivering replacements or warehouses full of spares, things like that. And so one place to take an idea, get an idea, if you're not already familiar with it, is Eric Arnham's warrantyweek.com. It's a free email newsletter, comes out once a week. Um, and he talks about the warranty industry. He pulls information from the public filings for publicly traded companies that talk about their warranty accruals, how much money do they expect to spend in the future on warranty, and then warranty expenses, how much are they actually spending. One of the caveats is if you find one of your competitors in there, it's hard, you shouldn't compare your warranty rate to their warranty rate because what's counted can vary. The way the accounting rules are is that one company can decide to count the call center or not count the call center in their warranty costs. If the call center is more of a training organization, then it's not a warranty expense. Where in another organization, they might do some training for people to learn how to use their product when they first get it, yet they're really there for repairs. And that's the bulk of their work. And each company defines that separately. So, but you do see trends, and the trends are pretty nice in many cases and illuminating as it reflects what's going on in the economy, but also what's going on with technology. And so warrantyweek.com does a really nice job to give you a rough benchmark of the trends in warranty expenses going forward. And as many of you know, warranty is I don't know, I think it's in the hundreds of billions of dollars total, but that's only a piece of the overall cost of unreliability. And I'm quite sure most of you are familiar with this overall concept. Yeah, and let's see, I'm going to come back to the question about or the notion about safety related failures, right? They add another level of cost, obviously. It doesn't take too many or even just one or the potential of one safety related issue for you to have a pretty large cost of unreliability or even recall. Fortunately, it's rare. Getting sued for negligence is still relatively rare. And if you do due diligence and you think through and design your product using the appropriate tools in the realm of safety, not just the standards, just meeting the standards isn't usually sufficient. You need to think through your technology, your customers, and so on. But the idea is that if you do due diligence in your design and you create a product that actually provides a function and does it safely, the warranty expenses and the cost of unreliability, it detracts from your profit. And years ago, I was surprised. One of the divisions that I was supporting um, had a really good product launch. And we did a lot of work to make sure that it was reliable when it got produced and shipped to the market. And the senior execs were upset that it was so good. And I don't. So I went to my manager and says, I don't understand this. Why are they upset that it's good? And he says, well, for whatever reason, the finance department did not believe us when we said the reliability of this product is going to be better than it used to be, the previous products. And they used their formulas based on history. And so they said it's going to have a 5% defect rate, for example, per year. And it's at 2%. And so they set aside all this money to pay warranties that never existed, that didn't turn out. So now they have all this extra profit they didn't expect. And I said, why is that bad? Well, they set that money aside for 3 months to a year in some cases. And they could have used that to invest in the next product. They could have used that to expand into a new market. They could have used that, a dozen different ways, but it was tied up because they expected it to be used for warranty. And okay. And he said what they're looking for, and the same thing Wall Street's looking for, oh, thanks, Chris, um, is they wanted it to be predictable, consistent. So if we deliver a product and it's at 5% in the past, they expect it to remain at 5% going forward, unless there's significant um, evidence that it's not going to be. Well, we ended up having a long discussion with the folks in finance to show them the science behind why we actually did predict what it was rather well. And so they started to listen to us a little bit better and adjusting their warranty accruals based on the technology and our science of predicting it. That doesn't always occur, but the idea is that the ability to estimate the reliability and the expected warranty costs is not, it's more art than science in a lot of organizations. Yet getting it right and getting it consistent is important. And so that's one part of it. And it ties into what the business wants to achieve, part of it, right? Where do they want to position themselves in the market? Is the most reliable or average reliability, but better features or whatever it is? How do we connect what we do dealing with the cost of unreliability with the overall business objectives? So, Jay, good question. If, how do we effectively quantify warranty costs? Well, the easiest one is let the finance people do it, right? And it usually includes things like call centers, return products, replacement products, and so on. What most of those organizations don't do is include things like engineering time to redesign a product to solve a problem, make it better. That's just part of development. Some organizations will pull out big projects that are really aimed at in reducing warranty costs as a separate project, but many don't. And so it's understanding that warranty is just a piece of the problem and cost of unreliability. One way to do it is to work with, and I did this a couple of times in organizations, is work with the finance team and find somebody that knows what's called activity-based accounting. It's different than what most accounting folks do in corporations, but it allows us to say, well, if we have a failure, right, what's the average cost to the organization of that failure? And this includes everything that occurs, including overhead for the failure analysis team, for example. Let's not just do warranty, let's do all of the activities that contribute, that get initiated when a failure occurs. And they, at least in my experiences, they all learn about activity-based accounting in school, but they never really get a chance to use it. So usually you find somebody that really wants to apply it. And it's informative. And what I found over the years, and I've heard from others that have done similar studies, that for consumer products in particular, the, the total cost of unreliability is like 2.5 times the retail price. So if you sell something for $1,000 and it fails, the average cost is $2,500 in order to impact your company just on that failure. Now, of course, it varies by industry and technology and all kinds of other things, but it's a starting point or a guideline for you to get started. And so warranty and the cost of unreliability and all these pieces of it, it takes time to get a rhythm in your organization and understand it both from a warranty cost of what's actually counted, plus the larger picture of what's going on. And that ties right into this next question idea here, Hojat, you're bringing up is the ROI, right? So simply getting a reduced warranty is just a piece of the problem. And not everybody really much cares about it a lot of times, right? If your warranty costs are already 2% of net revenue, you're not going to get a lot of interest in reducing it to 1.5% of net revenue. But if you can shorten or reduce the risk of shipping on time, not finding something late in the program that delays the program another month, that may be of way more value than what you're doing. And the book, I think I have it in the and I just realized I'm not in the right screen, but in the links information, there's Finding Value ebook and talks about all the different ways to get ROIs and all that kind of stuff. And so there's warranty is a piece of the problem. It connects to the business in the financials, yet understand that's just an element of what's going on. It could be time to market. It could be the cost of scrap in the factory. It could be development costs. It could be customer satisfaction. All of these different ways that value is created by having a reliable product. All right. I'm going to switch over to, I ended up let me make my slides a little bit bigger. Slide the chat window over to the side. Find myself even leaning into my screen a little bit too much. All right, customers, all right, they buy your product and they expect it to work. They want the functionality of your product, what it does for them, how it saves them time or provides a service or a feature that they don't have otherwise, right? Now, when it fails for them, it's not the the 2.5 times the retail price that costs them. They lose that functionality, right? Either they need to have redundant systems, or they need to have backup systems, or they need to um, pay the expenses of not having that function and doing something else. It, their response could be everything from it causes a recall of their product, or it shuts them down so that they can't process sales. Like years ago, I heard that if the servers for eBay goes down, they lose like $1 million an hour in sales, or $1 million a minute of sales, for example. And thus they have very sophisticated and robust redundancy systems, and so that they don't lose a minute of uptime on their systems. If you work in a factory, it's usually fairly well known what's the cost of downtime per minute in some cases, or per hour in others. If you can't produce products and you're already running at capacity, if you don't make it, you can't sell it, right? And if you do have excess capacity, it's not as big a deal, but it still costs you time. Even if it's just running the factory an extra shift, it still costs you that amount of extra money to produce what you should have been producing otherwise. The idea here is that customers that really do care about your product and want it to work, when they experience a failure, will tell you, right? Sometimes they want their money back, and sometimes they want the problem solved. And unfortunately, some organizations, and hopefully you're not in one of them, says, well, it was no fault found, or you abused it, or some other reason. What are we trying to learn from customers when they report a failure? They're taking the time to actually tell us, rather than take the time to go find another source for a solution. If we help them understand that failures, yeah, they do happen, but when they do, we learn and we move forward and we don't repeat it. that's a whole different story than let me get your replacement, right? After a while, and I had this happen with a phone, a smartphone I had years ago. After the third one failed for the same basic reason, I said, well, I'm going to find a different brand. But, and then they lose the customer altogether. Yeah, and Brad, and you're exactly right. Is the idea that, I mean, those big events can cause tremendous costs in loss of value in all kinds of ways. It's Yet those are relatively rare. Vast majority of our organizations, you know, we don't make the evening news, which is a good thing in many, many ways, but it's mostly because most of our products do really do work, right? And yeah, mistakes happen and damage occurs and designs are flawed, and we adjust and make it right and move on. Vast majority of what we do is in pretty good shape, right? But the idea here is that as we learn from failures and respond appropriately and fix things, that's great. Um, it's hard to do, right? Um, Yet, vast majority of organizations work very, very diligently to deal with failures and resolve them adequately, right? And so, yeah, and you're exactly right, David. The time to do this is way before your customers get it. It's time to do. Even still, we still get failures with customers, and we need to deal with it. Unfortunately, in some cases, it's like the unintended acceleration that Toyota saw, and it's really expensive. Or Boeing's issue with their software on the 737s, right? When it crosses that line and becomes a safety issue, then the failure rate can be very, very low, which is very hard to find um, in normal business, right? But I don't know enough details about either one of these to know why they're in the issues that there are. Hopefully, we'll learn more and be able to avoid it in our own organizations. And I mentioned some of the stuff about the cost to society. So look up Taguchi's loss function. I'm sure many of you have heard of it. It's hard to quantify, yet it's by far a larger, for vast majority of our normal products, it's a much larger source of expense to us all. We're all paying a tax when your product fails because the trucks are slower, there's more vehicles, there's less raw materials, and so on. When you think of it that way, um, it's it's important to get the reliability as good as we can with our products. Right. Well, that's tasks and that's outcomes, but what do we do? Right? What is it that we actually do that connects those things? Product. And a part of this is that we support decisions. And I know many of you that have been on previous webinars have heard me say this over and over again. The idea is that all the way through the life cycle, people are making decisions, whether it's what's the strategy that we're going to use to approach the design of this product, to do we build redundancy into our factory or not, do how do we select our suppliers, which suppliers we're going to select, which kind of components are we going to use, what technology we're going to use, all the way through. There's all these folks in our organizations and our customers that are making decisions. Now, I bet you if I asked you what's the bill of material cost for the product you're working on, right? You probably know that. And if not, you probably know exactly who to ask to find out, right? What's the cost of setting up that line? What's the cost? What's the of this concept that we're designing? There's probably a spreadsheet already in the works that lists out the costs. And then once they go to production is what's the volume prices of them and so on. What's the launch date? When are you going to turn this line on? We probably know that, right? What's the reliability of your product, right? We might know the target or the objective or the desired performance of our product in time to failure, but what is it today? What is the actual value of it? That's not easy to find. And very few of us have that on a day-to-day basis. Some of that modeling work we do and some of the testing work we do and analysis work we do, works at answering that question, but it's all in support of people making decisions, right? Is is this design better than that design? Is this supplier better than that supplier from a point of view of reliability? Well, we can run a test to solve that, or if we have the data, we can analyze it. And it's to say, yes, this one shows that it's better, or there's no real difference. That can help somebody make a decision, right? If we go to a halt test and the first 5 minutes into it, it catches on fire and it's not supposed to catch on fire, we now have information we didn't have before to say, this one might not be safe. Let's figure this out. That helps us make decisions. Is this design ready or not? I'm using an extreme example there. I actually had one that did that, a halt test that um, the product, we couldn't remotely monitor it except just looking at it. And the lights all went off on it. And we opened the chamber and it smelled like burning phenolic. It didn't burst into flames, but it melted some of the interior components. As a short occurred, and it drained all the power pretty quickly through this short, and it got pretty darn hot, and it melted some of the polymers. Um, so we thought, there's something not right here. So let's do some failure analysis, and it actually delayed the program until we got a good solution for that one. But it allowed us to make a decision with that information that we wouldn't have been able to have made, and it drained the appropriate one to otherwise. And so a big part of what we do is enable people to make decisions as they consider reliability. Right? They already know the cost. They already know the time to market objectives. They already know the launch date. They already know what functions they're supposed to be in the product. But we add the reliability considerations into that. Right? We often are working to answer the question of what will fail. Right? We'll ask designers, there's a margin on that. If you put that bracket there and it's loaded to its theoretical limit, well, what happens if somebody puts their hand on it and it goes 10 more pounds, gets onto that bracket? Will it fail? Oh yeah, it'll fail. Well, then it's not sufficient. We're not accounting for the variability here. Right? We don't have enough margin, so that will fail. And so on. We can look at the work we do with component derating and stress strength analysis and finite element modeling that primarily the development team does, but we certainly encourage and set up guidelines for them and all this stuff in order to minimize what will fail, knowing that there's all this variation out there. So we try to make a robust product by default and working on that throughout the organization. The other part we do is that when we do have a failure, it's like, hey, now we got something we can work with. Let's go figure out what happened here and how important it is to solve, right? What are the details? What's the failure mechanism? Will this occur in normal use? Will this occur in abnormal use that we should expect? Will this occur if we don't change something? And so we often are tasked with finding out what will fail. And we work very closely with the rest of the team to understand where there's risk of failure and then put that forward. So FMEAs and halt testing are great examples of what will fail. But it's well beyond just those two tools. And then we get called on to ask, well, when will it fail? One of my early projects was a brand new fangled way to package computer chips. It was called a ball grid array. So it was quite some time ago. And the development or the team said, well, we don't know anything about this attachment method. Will it last long enough in our application? And we had some thermal cycling. We had a bit of vibration. We knew other people had been using it successfully, but we didn't know in our application. So we set up an accelerated life test for our product and our design and some of the stresses that we're using and studied it and found that they were pretty darn robust. It's very hard to make a ball grid array fail once it's assembled correctly. And so we spent more time on the process of assembling them than we did on reducing the heat or the thermal cycling. But we often get asked, so will this last long enough? Now, on an overall product side, that's difficult to do because there's so many different failure mechanisms. So a lot of the what will fail helps us isolate what's likely to fail. And then we can answer the question of what's the time to failure distribution for that? And can we estimate that or model it? And so what will fail and when will it fail helps us fill in the gaps that people need to make decisions. It all comes back to making decisions. And so this is this is where we add value, right? We provide information. We take raw materials, which could be field data or vendor information or a schematic of a design, and we convert that into information about the reliability performance of the product, either what will fail or when will it fail, right? We use all kinds of different tools and techniques to get at answers to those two questions. And if the organization we're working with uses that information to adjust resources or to make selections of vendors or to uh, determine what is that an acceptable failure rate or not, for all the various reasons that a business may consider, then it's of value, right? One of the worst sources of value is I saw one of the worst examples I saw was a really, really good HALT program in an organization that really served a bunch of different divisions within the company. And I got a great tour of the facility. I talked to the engineers there. They were very diligent about their work and the reports they were writing, the failure analysis they did. They made recommendations for design changes. So later that day, I was talking to one of the directors of engineering, whose division sent samples to this HALT lab for testing. Samples. And I said, so how do you use their results? And he wasn't kidding when he said, I use them as a doorstop. They're big, thick reports that tell us our product is no good. And I just can't accept that. So I stack them over there. And when I need to prop my door open, they're really handy for keeping the door open. And he wasn't kidding. That's the only way he used them. And I said, well, why do you send 2 prototypes per cycle to the lab? Oh, we're required to. Right? But they didn't use them at all. And so it not only wasted he got his value as a doorstop, right? Which a piece of a wedge of wood would work just fine and would cost way less than running 2 prototypes of a computer system, basically, to destruction in the time of all the engineers and the capital and the report writing and analysis and everything else to be completely ignored. Not to mention, he had the information to alter the design to avoid those failures in the future, and it just ignored it. And so part of our work is to create the information, right? And then a big part of our work is to communicate that information to make sure it's heard and used so that in an appropriate way, such that if somebody's not going to use the HALT test, I'm not going to waste my time. It has to be useful to them in order for it to be of value at all, right? And so that actually use the HALT tests and help them double down on getting the benefit out of that procedure we're doing. And it should be clear to these other organizations then that, well, that really works for them. Let me explore that some more. Let me see by example that this stuff's useful. Or you have a heart-to-heart discussion with them or whatever it takes, but it usually is way more than just sending the report out. You need to make sure that what we're doing is connected to the decisions that are being made. So what do? We provide expertise. We have all kinds of skills, right? Our body of knowledge is full of stuff that other people don't have in their body of knowledge, right? To the chagrin of many people is we have statistics, which is both a good thing and a bad thing. I found that the best way to put a room to sleep is to talk about statistics of some data set, right? Except for this group, of course. The idea, though, is that we bring expertise into the table by looking at failures and the potential of failures in a different way. And it allows us then to influence the thinking and decision making of the group that we're working with and supporting, right? In some cases, we roll up our sleeves and we have unique skills that they don't have, and we can contribute that way. Other times, we have the background and experience that helps them to see a problem that they otherwise can't see, and so on. So it goes a number of different ways that what we do as a reliability engineer within the organization is much like a consultant, right? We're not there to say this has to change because we usually don't have that authority. Right? What we are there to say is that this is a risk. Here's some options for a solution for it. Let's consider it because we're part of the team and we're influencing their decision making, right? And here's the evidence. Here's our background. Here's our credibility. All of that fits into applying our expertise. The other part, and much more into the credibility part, is that reliability engineers are almost always there's one of the very few parts of an organization that works across pretty much everything in the organization. We work with marketing and finance. We work with development teams and operations. We work with maintenance teams and we work with call centers, or we can, or and in my opinion, is we should. We work with technicians to CEOs and everybody in between. It takes a different mindset to teach and explain a concept at different levels of the organization based on that person's experience and background. Yet we're the advocates, we're the leaders of the reliability work within an organization. We speak up for the customer's point of view or for society's point of view, right? And we also use it's good for the business as a way to convey the importance of what we do. So basically, besides just influencing decisions, there's design for everything out there, right? Design for X. Yet reliability is one of those very few roles within an organization that gets to see nearly every aspect of the organization, from corporate strategy to process stability on the production line and how they connect. Almost nobody else in the organization has that view of the organization. Unique perspective to the table, and we have the experience and background and skill sets to back it up, right? And so, to a large extent, what we do is help the organization understand why reliability performance is important. By actually paying attention to it, you can make a difference in creating a product or a system that meets the requirements and expectations of your customers. And it's in the benefit of not only us as an organization, but to the customers and to society as a whole. And my last question here is really, so when you're on that airplane or you're at a coffee shop and chatting with somebody and they ask, so what do you do? How do you explain it? What do you say that you do? Well, you're welcome, Carl. And thanks for the FMEA plug out there. It's a good stuff. I suspect a few of you have heard me explain what I do. Yeah, make sure things don't break. Work with engineering teams, make sure things don't break. That's a good one, Chris. I like it. This is kind of a test of, do you have an elevator speech of what you do? Okay, good one, Sean. And it's focused on how you use your tool, right? It connects to your business. I always say jokingly, is why I break things. I'm still a 10-year-old at heart, as a subtle a bit of humor, but it has a lot of truth in it. That I like breaking things, I should say, like interwingling. I wonder if that's as is what you meant, Christine. But yeah, a good part of what we do, even in an organization that is very siloed, as reliability professionals, we often are one of the very few that crosses many of those boundaries. You answer the question that business requests. So, and that looks like tools, Jay. I'd go a step further and say, in you know, why does business need RCA or RCA or predictive analysis? How does that help them? Does that improve uptime? Does that improve throughput or improve consistency of the products being produced? I mean, are you working to create those tools, or are you working to improve the process or improve the products? Thanks, Christine. Reduce costs, increase effectiveness, trustable. Yeah, all good, Carla. Yeah, good one, Ren. Nice and short. Yeah, make sure the machines are up and running, right? And Raleigh, excellent. So, I mean, the idea is you can say, oh, we do idea do these tools. I break things, right? I love breaking stuff, but that then has to lead to a discussion about why I do that. And many of you touched on that. Is the idea is that then we do what we do so that our organization can make products that meet or beat our customers' expectations, that we set up lines and maintenance programs that improve our uptime and process that creates a quality product consistently, right? If you add that why, it helps explain what we do, but more importantly, why we do what we do, right? What's our motivation? What's our driving force for this? Now, we do what we do. Products that's with your organization's priorities, more aligns with your own personal um, motivations for doing what you do, the better. Now, when that works, when that aligns really well, it's not a job anymore. It's an avocation. It's something that you want to do. And it helps to understand that I'm not just going to do I have to sit through an FMEA today. No, today I'm going to figure out where do we focus our resources so that we can solve the most important problems. It's a difference than just doing an FMEA and checking it off the box. You need to add that why a lot of times. All right. Thanks for attending, Evan. Appreciate it. All right. So basically, why is reliability important? It's because of the decisions that we influence. And it's within the organization during the development process, during manufacturing and the manufacturing assembly process, and with our customers. And when they make selections based on, in part, reliability of and the history of reliability of your products, we influence a lot. And our ability to pull our expertise together to bring about those changes is what we do, helping people make better products and systems and services that actually work products is why we do it, right? And we can quantify it and create value and point to all those things. But keep in mind that we're not just doing a test, we're helping somebody make a decision. And that's a big part of it. Okay, so I think we're right up about the end of the hour there, and I think that's my last slide. Let me go back to my conclusion piece here. Sorry, having that small screen to start with, and hopefully the small screen, the folks that were having trouble getting connected and so on, got something sorted out. And then, of course, I'll be posting a recording to this if you know somebody that really should listen to it or watch it. It'll be yeah, and then see a few folks that are regulars. Thanks for attending again. And a few new folks. Hopefully, you come back. We're like usual. I completely forgot what we're talking about next month, but watch for the notes on it. Invitations. So Brad, what's the IAM's version 1.1 document? I'm not familiar with IAM. I can make a guess, but I'm not really sure. Institute of Asset Management. Okay. And is that available if we look for Institute of Asset Management reliability engineering function? Would that be available? Yeah. You're not on the recruiting for new membership team, are you? Just kidding. No. Okay. I do know a few folks that are IAM members um, that I could probably get a synopsis of it. So I'll have to go ask some questions. Yeah. So hopefully, Brad, what I talked about is consistent with that. Obviously, I come from more of a product design background, but I have worked as a in a number of for clients, a number of ones. And the idea is similar though. You've got to work all the way through the organization in order to make change happen. I have. Okay, good. Thanks, Brad. You know, Chris, risk management is becoming more and more prevalent, especially at the enterprise level. We've been doing it for years. We just didn't call it risk management at the reliability focus. But project managers are starting to now talk about risk management, and enterprises as an organization are starting to talk about it. And it's a parallel for us, and we feed into those larger risk management programs. We're not the complete program, but we certainly fit into it.